quick video that we're going to do, and this video is going to be based on a virtual manipulative that's found at illuminations.nctm. That's the National Council of Teachers of Mathematics. And clicking on the interactive site, we are going to do diagonals of quadrilaterals, so basically just a geometry lesson dealing with diagonals and their congruency and if they're perpendicular based on the type of quadrilateral. Okay, so on the site it gives us three different types of quadrilaterals: one that appears to be a rhombus, one that appears to be a square, and one rectangle. Okay, and what I would probably do is just ask the kids first what they think. If the diagonals are going to be perpendicular, if they're going to be congruent, if they're going to be congruent and perpendicular. Okay, so that's always thought. So let's take this first one out, the rhombus, and we'll kind of expand this a bit. Now, just looking at it, because of a rhombus being the way it is, I wouldn't expect the diagonals to be congruent, because we can have a much greater distance from A to C as we do from B to D. Okay, so if my diagonals bisect each other, I still wouldn't expect them to be congruent because of that distance there. So I just have the students make guesses based on the shape itself and kind of see what they say. Okay, now this appears to be a square, so I would ask them if they expect these to be congruent. Well, they might say that because I have 90-degree angles that the distance for my diagonals is going to be the same, and that if they bisect each other here in the middle, that they should be congruent. Okay, and then the last one, a rectangle. Would these be congruent? Well, these would possibly be congruent, but the question would be, are they going to be perpendicular to each other? Because looking at this, it doesn't look like a line crossing here from L to N would cross a line from O to M at a 90-degree angle. Okay, so these are the questions that I would ask the students ahead of time and to make their guesses based on this. So what we're going to do now is actually pull one out, and we'll show the bisectors. Okay, and if you look at it, the bisectors are not congruent. Okay, because the distance I have here from E to B is going to be much different than the distance from, let's say, E to A, because I could take E to A and stretch it out and get quite a bit of disparity between the two bisectors, okay, or between the two diagonals. But the sections themselves do bisect each other, and they bisect each other at a 90-degree angle. Okay, so E to B is going to be the same as E to D, so it is bisected and everything. So we'd see how many of the students guessed correct on that. That even if I change the angles, that let's say the distance from A to C, as I move this back and forth, that's going to stay the same, and the distance between EB and ED is going to stay the same. Okay, so clearly it bisects at a 90-degree angle, but they're not congruent. Okay, so then I would move them on to the square. Okay, now based on this, initially all of the perpendicular bisectors are congruent. Okay, and no matter what I do to the size of a square, they're going to be. Okay, I rotate it, stretch it out. Okay, but it stays the same, that all four sides, or all four perpendicular bisectors, I should say, are always going to be congruent. So I'd see how many you guessed correctly on that. And then last with the rectangle. Okay, we could move the rectangle around, and you're going to see that these are all the same, no matter what I do to it. No matter what size, I could stretch it out some. okay, that those are going to be the same. So we have a couple of categories that these fall into. Number one, we could look at which quadrilaterals have perpendicular bisectors. Okay, well, the perpendicular bisectors are going to be my rhombus and my square. Okay, and if we just ask which have congruent bisectors, well, the congruent ones are going to be the square and the rectangle. And so kind of the overlap or the intersection of those two groups is which has congruent perpendicular bisectors, and that's going to be just my square. So I try to relate possibly what it is that causes the bisectors to be perpendicular or to be congruent or something like that. And we might look at the attributes of each one of these shapes and say the congruency seems to be linked to the quadrilaterals that have 90-degree angles. Okay, so looking at the square and looking at the rectangle, we notice that no matter what size we make them and everything, because of the fact that they have 90-degree angles, that there's a congruency between all of the bisectors. Okay, and then might ask, well, what makes them perpendicular? Well, maybe the relationship, or what makes the bisectors perpendicular, is the fact that with the rhombus and the square, they have congruent sides. Okay, so we'd kind of relate this to the students and, you know, have them think about that if we have congruent sides, okay, then our lines should cross, our diagonals should cross at a 90-degree angle. Whereas if we have congruent angles or 90-degree angles on both shapes, then what we're going to have is congruent bisectors. All right, so that's the congruent and perpendicular bisector lesson.